Hey there, all you out there in TV land. Welcome to Fundamental Trig Identities. Anyway, we're going to pick up, I'm going to just do a bunch of examples. These are going to be ones that we may have done in class. We may not have gotten time to do in class, etc., because we're, again, laying down the very good, big basis for doing some real formal identity work starting tomorrow, or at least the next time I see you in class. So, on this one here, number 4, we are going to try to turn, let me get my pretty pen out again. We are trying to turn this into 1. And so when you see a problem like this, especially if you've got multiple fractions in them, the first thing I would do is simplify and put it all together. So like in this case here, if you need a common denominator, you're going to get a common denominator. But first things first, and again, I would get into the habit, the practice, the what have you. You need to write down the initial step, okay? Because if you're going to have an argument and you're just going to assume that everybody read everything or knows all of your position or where you're starting from, that's not, you're not going to have a good argument. If you've had taken any of the philosophy stuff here, you know that. You have to reiterate your position. And then from there, you can combine this. Now again, remember, common denominator, once you have that, you don't do anything with that. And then we've got that. Now, as I said in the past, you've got, whenever you see a 1 and a squared term, you should be looking to see what else we can do. Now, I'm going to jump over here to the trig cheat sheet, and I would highly encourage you to write your own of this. I understand it's going to be tempting to like do a screenshot, or, you know, hey, can I have an app for that? Or could I like just print it out? Well, if you write it out and make your own, it's going to be much, much more helpful. If you look over here again, now notice we've got 1 and a cosine. Now, here we have 1 and a cosine and a sine. Yay! So that's going to be the one that we're going to want to do our work on. However, what we do also need to do is that we need to make it look the same as what we have. And again, it's always just going to be basic algebra. So if I subtract cosine off on both sides here, so subtract cosine squared minus cosine squared, okay, notice now 1 minus cosine squared x is equal to sine x, and that is what we'd end up using over here. So we'll come back over here, and then we will comment, this is cosine squared x plus sine squared x is equal to 1 through Pythagorean theorem here. 1 minus cosine squared x is going to equal sine squared x. We get our 1. Sorry, that does look like an O. Again, I'm not going to say this enough. If you're thinking, oh, I can do that, that's easy, why should I bother writing it down? The whole reason why you're writing this down is so that you can go through the steps, the habits, the looking for things, and all of that. I'm not necessarily trying to tax your mathematical knowledge here. Okay? Starting you off with, it's like if I was teaching you how to do jigsaw puzzles, I'm not going to start you off with a 500-piece jigsaw puzzle that doesn't have a border on it. I'm going to give you one of those 12-piece, if you're lucky, probably now at your age, probably a 12-piece one with the borders on the side that you can pop outside, and then you can slide them all in like, you know, your 3-year-old nephew might play with. Okay? We're starting small. Next problem, same idea. So now this is going to be probably, okay, so we're starting here, and we're going this direction. Now, the one thing that should really be jumping out at you, well, ask yourself, what's jumping out at you at this problem right now? Well, Mr. Hayes, we have a 1 plus sine. Isn't that supposed to be like 1 plus sine x, sine squared or something? Well, yeah, okay. And this right here, this whole idea, remember, of x squared minus 1, actually here, let me do it more general than that. A squared minus b squared. Remember the difference of perfect squares? A plus b, a minus b. That is going to come around and play itself a lot now. In fact, if I had to ask you that, okay, what would like 1 minus x squared factor out to be? Oops. So one of the things that you need to kind of keep in mind on problems like this is, again, Pythagorean identities are going to come back and they're just going to be like the biggest rock stars of your identities. Okay? Now, like we've talked about in the past, you need to try, like in this case, we need to get rid of the cosine. And if you're not sure what to do, and the reason why we have to get rid of the cosine is because we know our answer is going to be 1 minus sine. So again, you know, the question is, can I write cosine squared as something else? And that's going to, again, come back to the Pythagorean identity. Cosine squared, I could rewrite as 1 minus sine squared x if I subtract x from both sides. So, start off with the original. And we're going to do it now through the Pythagorean identity. Get that. Now, the answer is not, oh, divide the 1 and divide the sine in, and then you get 1 minus. No. Not legal. For too many reasons that I've already, you know, dealt with it. However, you remember how yesterday how we factored out the greatest common factor? We are going to factor this. What does 1 minus sine squared equal? Well, hey, look. That's going to break down into 1 minus sine A times 1 plus sine A. Now things can divide out. This is the 1 plus sine A's are now both factors. That whole, and this is why factoring is so important. You never know where it's going to rear its ugly head. Oops, Rowan. Go ahead. Ooh. So we're trying to take cosecant b over 1 plus cotangent squared b is equal to sine b. Again, you're not sure, but you know that there's 1 in a cotangent, 1 in a square trig function. Pythagorean something, right? Bop on over. We had what? 1 in cosecant? Yeah, no, 1 in cotangent. So, oh, check that out. 1 plus cotangent, or cotangent squared plus 1 is equal to cosecant. So, start off with the original. You know what? I'm going to do this. Change base. So then that's going to become cosecant squared b. And this is due to everybody's favorite Pythagorean identity. At this point, you'd be like, hey, we can divide stuff out, right? Yeah. Now, if you don't see that this is already sine, go back to your cheat sheet. Hey, all right. 1 over cosecant. That sounds like a reciprocal to me. But sure enough, there it is. So, pull that over. Some years I like going horizontally. Some years I like doing my explanations vertically. The vertical one kind of makes some sense because you can like change things. I don't know. Whichever way floats your boat. All right. Let's try some more. Ooh. Hit pause. Do this one. You should be fine. All right, welcome back. I certainly hope you see this as a difference of perfect squares. Or the factors of a difference of perfect squares, I think, to be more precise. And again, you see a 1, you see a sine squared. Just double check that's not adding, because if it's adding, then you're stuck. But there you go. Again, this is not intended to be extremely hard. This is intended for you to just to get through the process and get an idea around some basic skills, like looking for different perfect squares, looking for how to simplify things, using the Pythagorean theorem. And if you're waiting, well, I suppose if you're waiting until it gets hard before you do anything, you're probably not listening to this podcast. By the way, today's secret word for the first person in each class who hears this, who comes and tells me it, will get a favorite student point. Today's secret word is, let's make it Saskatchewan. All right, thanks. All right, now, ooh, this one's really interesting. Now, we're starting here. So, and again, if you're not sure where to start, I would start by just simply writing down the first complicated side. And I say that primarily just for the fact that you may, just by writing it down, you may see something. So like here, by writing it down, you should hopefully see that you're having a sine squared and a sine to the fourth. And given the fact that you're adding those two, that should be thinking, I wonder if I factor those out. Because again, do you have anything over here on the chart of wonder that has anything to the fourth power? No. Does that mean that you can't use it? No, because obviously something squared is to the fourth power. But you know, it would at least be worth your time to say, what would happen if I pulled the sine squared out? Because obviously, I mean, like right here, you're not adding, so it's not equal to 1. If you kind of were leaning that way, you kind of got the right idea. I mean, at least you're thinking in the right direction. Anything strike you here? It should. Oop, I forgot the A. Sorry. This is just equal to 1. Dear old Pythagoras. Are you going to have a theorem named after you someday? Are you going to be remembered for all eternity? If not, what are you doing about that? All right, so obviously that's 1. This will go away. Now the question is, how do I get sine squared up to 1 minus cosine squared? And you're like, oh, well, remember, cosine squared plus sine squared is equal to 1, so that's going to equal that. So by Pythagorean and a little math. I think I've got one more to go through and do. No, I take that back. That's it. All right, so there's some stuff in case we didn't get through everything in class or you missed things. Big takeaway. Get a review, or get a master sheet of all of your identities. Other takeaway, do the problems, get used to what it's supposed to look like so that you can do everything else later. All right, so I will talk to you guys next time you're in class. Otherwise, for those of you guys tuning in overseas, thank you for joining us. If that's the case, just go ahead and email me the secret word. That would be fine. Anyway, talk to you later.